So this is the first major chapter of this unit. The chapter we previously did was just basic understanding of how to do graphs and then just kind of how to read them. But this is now going into trends and patterns and interpreting and lines and all these different things. So it's just good to remind ourselves, based on the last video, what an outlier is. So an outlier, and it says right there, it does not fit. So we did that one. That's that on the last chapter. It's that person who studied for, I think, 6 hours but only got like 19% or something. That didn't really make any sense. So it's an outlier and it doesn't fit with the pattern. Independent variable is the variable that you do first, and it's the one that is just independent of everything else, and that's usually time. But what's important to know is it's always on the x-axis. The dependent is the one that is, well, it's dependent. It depends on whatever you're looking at. And so that's on the y-axis, and that is usually like a test score or the distance that you've traveled. So for the distance that you traveled, it was dependent on, it was based on how much time had gone on. It was um, so that's why it's always the dependent one, because it depends on the x-axis. The linear relationship and non-linear relationship. So in grade 10, we focus a lot on linear relationships. And then in grade 11 and 12, we do curved relationships. We call that here non-linear. And that's what we're going to be looking at moving forward. So it says for each of the following graphs, circle any outliers, uh, identify the independent and dependent variables, identify if the relationship is linear or nonlinear, and then state any trend, if there is any. So is there any outliers for this in this graph? It's like, well, that follows a trend like that. There's nothing that is like, it'll be really obvious. It would be something like right there or something like up here. And so no, there is no outliers in this one. The independent variable, you're going to have to remember that's your x axis, and the dependent is going to be your y. So in this case, the independent variable is, I'm assuming this is height. Yeah, so this graph goes like this. So the independent is going to be our height. And then our dependent is our pressure. Oh, height we should do in meters. And then here is our pressure. And that's in kPa. Now, does this pattern look like a linear? And so to me, it does. It'll be really obvious when it's a curve. So, I mean, yes, you could kind of do this if you were just connecting the dots, and it's like, well, that doesn't look like a line, but that's not what we're doing. No data is ever perfect. Just in general, it looks like it's following a trend of a linear. So I would box this, yes, it is linear. And what actually is the pattern? What is the trend? So the trend is as the height, so I'll start with as. So as the height, is the height going up or the height going down as we move along? So it looks like the height is going up. So as the height increases, the pressure looks like it's also going up. 20, 30, 40, 50, 60, 70, 80, 90. So the pressure goes up. So that's, oh, sorry, the pressure starts up here and then it's down here. So the pressure is decreasing. So as the height increases, the pressure decreases. So if you compare that to our last drawing of the hours of studying, that trend looked like that. So the more time you spent studying, the better your mark got. But our drawing here, in this one, now looks like this. And it says, as the height increases, the pressure is decreasing. Now let's take a look at the next one. A speed of skateboard over here and the height of the ramp. Okay, so circle any outliers. In this one, yes, looks like it's way off there. Independent variable, that's the x-axis. Dependent is the y. So the x-axis is down here. The y-axis is up here. And this is the height of the ramp. So this is the height. I'm just going to write of ramp. not going to write all the words. So it's the height of ramp and then the speed of skateboarder. So you can probably just do speed, just because I'm a little bit lazy. Is this linear? Is this look like it follows a line? And I would say yes. You should usually see a few lines, a few dots on either side of the line. That's kind of what you're hoping for. Yes, it is linear. It doesn't have like a giant curve to it. And the trend. Well, this kind of makes sense that if the skateboard ramp if the height gets higher, well, then your speed is also going to go up. So as I like to write this, as the height increases, it's always as the x-axis increases, as you're moving along to the right, what is happening to the y? And the y-axis is things are moving up. So as the height increases, the speed increases. That's what this graph says. So, I mean, if you can take a look at 2, when the ramp is 2, I don't know, 2 feet, 2 meters, doesn't say, I have a speed of 4. But then if my ramp is 5, I jump up to a speed of like 7. So the higher the height, the higher, the faster my speed. Okay, so this is what I was telling you before. This is clearly a non-linear. It has this curve to it, and it's very obvious. But we still have independent variables. Our independent variable is our x-axis. So that's right here. And then we have our y-axis. So the x-axis, I can't read it. I'm going to scroll down here. Okay, it's the speed. And what is it? Kilometers per hour. And dependent is our fuel consumption. In something. I don't know what it is. Liters per 100 kilometers. There we go. And the trend. So the trend for this, it looks like it kind of has two trends. It looks like it's heading down. So from 0 to 60, it's heading down. And then from 60 onwards, it's heading up. So from 0 to 60 kilometers an hour. So from 0 to 60 kilometers per hour, our fuel consumption decreases. And then from 60 to, I don't know, how far do I go? 120 kilometers an hour. The fuel consumption goes up. And goes up, I'm just going to write increases. But you could use the word goes up or goes down here. So from 0 to 60, our fuel consumption is decreasing. So from here to here, that's from 0 to 60. We are decreasing our fuel consumption. And then from here onwards, from 60 to 120 kilometers an hour, we are increasing. So yeah, that would be our just being able to read these graphs, these linear, nonlinear graphs, and looking for trends.